Hello, good afternoon, everyone. Welcome to this web symposium being organized by Composites Excellence Center of Asia, CECA, and in association with Link Composites Private Limited and Lantor Composites. So I'll quickly brief you with today's agenda and let's kickstart the symposium. So welcome everybody. A very warm welcome. It's very hot outside, and I hope we're gonna learn a lot about lightweighting of composites, all the solutions and development being provided by Lantor Composites today. I'm really excited to know more about it. But before that, I'll quickly brief about today's agenda. So today we are going to have like the topic is Lantor solutions and developments for lightweighting of vehicles. That is being presented by Lantor Composites in association with Link Composites. So today's speaker is Mr. Ali Khani. I'll quickly brief about him in a while, and I'll quickly brief about CECAASIA for first 10 minutes, and then it will be Ali who will be speaking, and then we'll have a small Q&A at the end of the session. So if I quickly brief about Link Composites, so Link Composites Private Limited would like to introduce themselves as a leading supplier of FRP raw materials for composite part manufacturers in India. They currently operate in 13 locations and are happy to serve hundreds of satisfied customers. And as they say that the company you can depend upon, you can see more about Link Composites on elink.co.in. I'll quickly share about Lantor Composites. So Lantor is the expert when it comes to textile solutions in your FRP product. Whether you need to lightweight a monolithic shell part or to produce products fast and with optimal surface quality, Lantor has the solution for you. And as they say, Lantor makes it lighter, better, and smarter. So you can see more about Lantor Composites on lantorcomposites.com. I'll quickly share about today's speaker, Mr. Ali Khani. So within Lantor, he is responsible for business and application development within the advanced composites market. His background is mechanical and aerospace engineering with a focus on composites. He earned his PhD in aerospace structures and computational mechanics from Delft University of Technology in 2013. During his studies, he was involved in different projects for development of novel methods for optimization of manufacturable composite structures with the aim to reduce their weight and improve their performance. And he has been working as a composite specialist at different companies and segments, from startups to giant material producers such as Sabic, serving clients from aerospace to automotive and marine industry. So we are very grateful that we are having such a speaker today who will be sharing Lantor solutions to us. I'll quickly share about CECAASIA. So CECA Composite Excellence Center of Asia is Center of Excellence that has been set up by adapt and accomplished professionals from composite industries, academics, and research organizations. CECA is supported with ceramic technologies, polymer technologies, material scientists, chemical engineers, and geologists, we all know. CECA is continuously supporting composite industries in their growth journey through technical support, technical trainings, project consultancy, and arranging such technical and webinars now and then. And CECA especially focuses on future generation to support and guide them for securing employment in composites field through support in their education, training, internship, and finally selecting the right career, including higher education guidance in foreign universities. The mission of CECAASIA has been very clear that they are dedicated to create a better everyday life in the composite manufacturing system and their professionals in Asia through lean techno-commercial business transformation. Working together globally with the team of passionate, talented, and dedicated pool of technology leadership to meet and greet the needs and expectations of tomorrow of composites has been the vision of CECAASIA from day one. If we talk about the services, so they deal into three segments. Like if we talk about materials, we deal in industries who are associated with who use these materials as raw material or which are part of their raw material or product, which is aramides, carbon fiber, core, epoxies, natural fibers, polyesters, prepregs, and more. If we talk about processes, we give consultancy and project management to additive manufacturing, curing technology, filament winding, infusion, machine drilling, pultrusion, RTM, and much more. If we talk about the markets that we cater, it is aerospace, automotive, defense, marine, sports and recreation, and much more. The CECA The core support team of CECA includes Dr. R.K. Singh, N.C. Sharma, Chandran Kunal, Dr. Anshuman, Francois T, and Hiral Parekh ma'am. If we talk about memberships, individual and annual membership is absolutely free. The honorary life membership is free, but it is being nominated by the CECAASIA team. The corporate membership, which is a paid membership, which has ample amounts of benefits. The annual fees is in Indian rupees, it's 11,000 and 160 USD per annum. You can visit CECAASIA.com/membership to download the forms and see the benefits. If we talk about the memberships, the professionals, academicians, professors, researchers, and students associated composite manufacturing, polymer plastic industries, R&D, universities, research and training organizations are invited to become the member of CECA. The individual membership is absolutely free. Come and be the villager of World Composite Village. Help yourself and the composite fraternity. So CECAASIA has that big vision of making India the hub of composites. So be part of it, be a CECA member because it's absolutely free. Honorary memberships, as I was saying, that honorary life membership is granted based on recommendations from the members, core members, and professional partners, and it is being nominated by CECAASIA. Normally, there are people who have served composites field for more than 20 years and have some memorable contributions in their areas, and this membership is absolutely free. The other services that CECA provides is CECAASIA Manpower Data Bank, which is a free service to the fraternity. CECAASIA Community, which is a bi-monthly newsletter. CECAASIA Directory, it's an online directory being, it is under development, and you will be soon seeing it on CECAASIA.com, where you'll find all the organizations, industries, experts, and designers, and everyone who is related to composite industry can be seen there. We also will portray our empanel consultants on the directory, and of course the tool designers of CECAASIA. If we talk about the trainings, we have both online and offline trainings, short-term and long-term courses divided into technical trainings on composites, quality improvement trainings, specialization courses, and we also provide customized courses. In short-term, offline, online courses, we have composite material processing analysis and optimization. It's a 3-day course. It's a very amazing course. Then we have a course on composite materials and structures, mechanics of composites, and CFRP. You can visit CECAASIA.com to see all the upcoming trainings as well. If you talk about the specialization courses, that is one of them is Six Sigma certification courses. The Lean Six Sigma Green Belt certification and Lean Six Sigma Black Belt certification are 4 days and 6 days online in-house training can happen. Like we have both weekend and weekdays courses. You can visit CECAASIA.com again to see them. If we talk about the long-term courses, we have 2 amazing courses. NDT for Advanced Composites. It is being taken by Mr. Chandran Kunal, who's a very famous NDT expert. And the second one is Mechanics of Composites. Moving ahead, these are our success partners. We're very happy that these have been our touch points from day one. So we're very happy and proud to be associated with all of them. And from today, we have Lantor with us and Link Composites. So thank you once again, both the organizations, for being part of it. I'll quickly share about SYNC. SYNC is the first Composite National Conference going to happen in September. On 17th, 18th, and 19th. This is one of the biggest event that you will ever see in India on composites. And there's many things cooking up behind SYNC. Soon we'll be sharing much more details because this is going to be very grand, and this is going to happen in association with ATIRA Ahmedabad, SSME ISRO Ahmedabad, and National University Vadodara. And we are also cooking up many things backtrack. So soon you will be getting more information on SYNC. Meanwhile, you can register on sync.cecaasia.com. And I have something more exciting for all the composite fraternity, and that is CAMEX. CAMEX 2022 is happening in Anaheim, USA, from October 17 to 20. And we're very happy to announce that Composite Excellence Center of Asia, that is CECA, is partnering CAMEX for the event. And this is like a very proud partnership, like one of the biggest achievements of CECAASIA in recent past. So we are very happy, and I'm really happy to share that like it's a proud moment for CECAASIA that it is organizing partners of an Indian pavilion at CAMEX 22, and like whoever will be the part of pavilion who will be coming and exhibiting with us, will get a short support in all respects, including MSME International Cooperation Scheme. If you're eligible for the same, you will surely get the benefit of the scheme. CAMEX exhibition is already enlisted in the approved list of events for visit for MSME. So if you are an MSME and if you really want to come exhibit yourself at CAMEX at the Indian Pavilion, which is being like CECAASIA is the organizing partner of that Indian Pavilion. So please do write to us. You can write to us on connect@cecasia.com and you will get all the information about it. So this is a very, very proud association that they're going to have. So it's a date with Composites. So please do, if any of the Composite fraternity is interested in exhibiting at CAMEX, please do let us know. So with that, I believe I'm done with introducing CECAASIA to two, like always. So thank you again, everyone, for joining today. I'll pass on the baton to Mr. Ali Khani. So welcome, Mr. Ali, if we can hear you.
Hello, good afternoon.
Yeah. Good afternoon, Mr. Ali. So thank you so much for joining. The stage is yours. You can start screen sharing.
Thank you. I hope you can see my screen.
Yeah, absolutely. Can see. Please go on.
Great. Thank you, Composites Excellence Center of Asia and also Link Composites for this opportunity to introduce Lantor products and solutions for lightweighting of vehicles. Just a first note, as you have seen probably in the announcements, there were two speakers. Unfortunately, my colleague, Mr. Wardstein, he got sick, so I'm going to take over his part also. So why this topic? Or in other words, why we are going to talk about Lantor solutions and products for lightweighting of vehicles. As you know, like nowadays, environmental issues, CO2 emissions, like fuel prices also skyrocketing, and the new trend of having electrical vehicles. So these are happening. These are all the challenges which are happening at the moment. And they are kind of related to each other, and the solution should be in the lightweighting of vehicles. For example, in terms of electrical vehicles, which is a fast-paced development at the moment, we see still some consumers, they are hesitating in terms of range of these kind of vehicles. They have a kind of range anxiety, so they don't know if they take this kind of vehicles, would it be able to take them from one place to the other place with only one charge? So I think all of these challenges in terms of environmental issues and in terms of fuel consumption, yeah, they can be addressed with lightweighting of vehicles. And we think at Lantor, we have solutions and products which can help in this direction. So in the next, I think, 45 minutes, I will try to introduce Lantor, its products, solutions, and also give you some examples of applying this material in lightweighting of vehicles in the transport segment. So Lantor, a little bit about Lantor. Lantor is a production company located in Netherlands, a city which is called Veenendaal, located in the heart of Netherlands. The company is more than 60 years old, and at the moment it employs about 140, 150 people. And we are specialized in technical textiles. What we do is that we produce non-woven textile and we convert it to different end products. So there are several product groups which we have. but two of the, let's say, biggest ones or the main product groups. One is composites, where we produce core materials for sandwich laminates, and also surface materials for, let's say, surface quality, surface product protection of the laminates. And then the other group is for cables, where we are producing protection tapes for example, protecting the wires against humidity. We are serving different industries, and we are serving them worldwide. A large portion of our customers goes to marine, but also we are very active in other segments like automotive. So in the next slides, I would focus on the composites products. So probably the first questions which comes to your mind is, yeah, what is Lantor core made of? So most of our products, they are made of polyester fibers, which come from recycled bottles, PET bottles, basically. So basically, we process these polyester fibers in our production facility, and we make a non-woven veil, which is a base of most of our products. Later in the process, we make a mixture of microspheres and binders. So microspheres, these are kind of small balloons in the micron scale, which include a liquid hydrocarbon, which under temperature, it becomes a gas, and it expands the microspheres. So they become bigger. And basically, these are very important elements in our cores, which are serving the lightweighting purpose of the core. So basically, these are like empty balloons in the core. So using this mixture, we print it on the veil that I mentioned, on the non-woven veil. We print this mixture, and then in a process, in this kind of machines that you see here, we basically fix the microspheres in their place. And as you see, our products are coming out in the form of rolls. So if you look at our products under microscope, at a larger scale, if you look at the surface of the product, you see this kind of structures. Of course, different products, they have different patterns. Here you can see a hexagonal pattern where you have some channels here, and then an island in the middle. This island is filled in with this kind of microspheres, expanded microspheres. If you look at microscope, you see this kind of microballoons. And there are these channels around which help for the resin to flow. So if you look at our cores, we have different brands, and basically the way we name them is kind of related to the process in which they can be used, or they are aimed for that process. So Corvette is designed for open mold processes, for hand layup. Storic is designed for vacuum infusion. And Techcore, which is a relatively new brand, this is designed for higher pressure, higher temperature applications and processes like autoclave, thermopress, RTM, and this kind of, for example, wet compression molding, this kind of processes. And we have surface veils for improving surface quality, which is called finish mat. And we have also a combination of different products, like a layer of core together with a layer of finish mat, and together with a layer of reinforcement in one product, which we call it skin core. So how are we applying these cores? for example, if you have this kind of laminate, which has several layers of glass fiber, and you have a bending stiffness, a certain bending stiffness, an alternative to this laminate would be to substitute these two middle layers of glass fiber by one layer of Corvette, and still having the same thickness and the same or kind of still enough bending stiffness in the laminate. So basically, by using Corvette instead of two layers of glass fibers, you are building the thickness still. Instead of placing two or multiple layers of glass fiber, you're just placing one layer of Corvette, which saves you time. And also it saves the weight of the glass fiber by substituting Corvette. And also it's saving the resin consumption and also saving the cost. So another way of using or another advantage is when you want to move from a hand layup laminate to a vacuum infusion laminate. So what happens is that because of the vacuum pressure, you would have so basically this is the same stack, but you see here you have much less thickness because of the vacuum and because of less resin absorption of the laminate. So the less thickness, it translates to a stiffness, a bending stiffness, which is not enough for your application. What you can do is you can place a layer of Soric in between these glass fiber layers, which helps you to still build up the thickness and still have a good stiffness. But also it helps you to have a good resin flow. Basically, Soric, because of the channels which I showed you, it can easily help to facilitate the flow. And then you don't need to use extra, let's say, material for facilitating the resin flow, like flow mesh, for example. It's not needed. So what I would do here is I would go through these products one by one, introduce these products. I would also show you some films, how these products can be used. And at the end, I would show you some applications in the transport segment. So Corvette, as you see, we have two types of Corvette. We have the Corvette XE and we have the Corvette XM. You can see the XM here and the XE here. There are different thicknesses starting from 1.4 millimeter going up to 10 millimeter. Here you can see the roll length, roll width, the resin uptake per meter square, the dry weight and the density of the impregnated core. Here I have a film from my colleague, Mr. Wardstein. He's actually showing how to apply this Corvette in a laminate. I think that shows you a lot how to apply. So I don't need to talk about it.
Laminating with or without Corvette starts with applying a layer of resin to the mold surface. It is important to back wet fiber layers, which prevents air entrapment even after rolling the aeration roller. The first layer of glass is rolled thoroughly into the resin before adding more resin as required. We recommend to apply the core mat on a wet or slightly gelled glass layer to get an optimal bond between the core and the glass. We do not recommend to wait until it's fully cured. Should your project not allow this, we recommend to sand the laminate before applying the core mat, even if you've used a peel ply. Next up is the core mat. For this panel, we use the 4mm Corvette XM. The 4mm thickness creates the stiffness in this panel that we need for the application. It is important for the panel strength to fully wet out the core mat. To make sure we fully wet out the core mat, we pre-wet the front side of the core mat, which is the smoothest side. We can roll the resin in the core mat without applying any force. We just have to make sure that the resin is spread over the surface of the core mat. To accomplish this, we use long motions, stretching the full length and the full width of the ply. See resin remaining on the surface, we can turn over the core mat to the backside and position it on the glass fiber. It should be done for all core mat products of 3mm thickness or more. On the backside, we can see that the core is not fully wetted yet. This is why we use this two-staged approach. Now we can proceed with saturating the core. We do not have to measure the amount of resin we use because it's not possible to overfill the core mat. The structure of the fibers and microspheres are chemically bonded to each other, so it will not expand when resin is added. Now that we are confident enough resin is applied, we can check the saturation level using our roller. When we move our roller over the core mat, again without using force or pressure, there should be a small front of resin being pushed by the roller. When this is the case all over the ply, we are done laminating core mat. We apply the second layer of glass fiber to the backside of our panel on the still wet core mat. Do not allow the resin in the core mat to cure when there's still excess on top. Instead, always laminate a thin layer of glass fiber on top and peel ply as needed. Core mat is a core material, and by far the best results in panel strength and durability are obtained when the core mat is laminated in the middle between fiber reinforcement layers. when we are confident the glass layer is fully saturated, we can apply a peel ply to cover the backside. Peel ply removes excess resin after cure and creates a good surface for coating or adhesive. Although peel ply is not a structural layer, we make sure that the layer is fully saturated.
After laminating, we let the resin cure for 24 hours at room temperature and post-cure it at 80 degrees centigrade. This is to make sure that the polyester is properly cured.
Yeah, I have another film here. I think this is important to see this one. This is a 3D mold. Basically, one of the advantages of Lantor products is the flexibility and drapability of the core. So basically, you can easily, without any need for post-processing of the core, you can easily drape the core to any kind of 3D shape. As you see here, this is a 3D mold. Actually, the operator is placing the first glass fiber layer here. And subsequently, as you will see here, he would place a layer of core mat, this one, easily, and basically drape it to the shape. So he will you will see it in the coming minute. Yes. So moving to the next product, Soric, which I mentioned, is aimed for vacuum infusion process. We have different Soric grades. As you can see here, starting from Soric SF, which stands for standard flow. You can see these kind of hexagonal patterns in Soric SF. Then we have Soric XF, which is for extra flow. So basically, if you need to do your vacuum infusion faster, you can use this product because it has larger flow channels, which allows for, let's say, higher flow. Then we have Soric LRC, which stands for low resin consumption. So if you need to have a lighter construction with less resin absorption, this is the choice, which has very small flow channels. And then we have the Soric TF, which is used for top finish. So here you don't see any kind of hexagonal patterns, but you see a random dot pattern. This is the data sheet. Again, as you can see here, starting from a thickness of 1.5 millimeter up to 10 millimeter. Different roll lengths, widths, resin uptake you can see here per meter square. The dry weight of the core, the density of the impregnated core, and the thickness loss. So under vacuum, you would have something around 10 to 25% loss in the thickness, depending on the product. And all of these products, they can be used up to 170 degrees as the processing temperature. So if you look at Soric, we see this kind of islands and then the channels around it. So first of all, Soric can have two different roles in your laminate. It can be used as a core material to build thickness and help you to have the same bending stiffness as before, or higher bending stiffness. But also it helps in enhancing your process. It helps in facilitating the flow. And the flow facilitation happens through these channels. So basically this Soric has two parts. It has these cells or islands, and it has these channels around it. So these cells, they don't have resin uptake, or they have a very little amount of resin uptake because they are full with the microspheres. And they have low compressibility. So basically under vacuum, they may lose about 10% of their thickness. And then you have the channels, which helps for resin flow. And also after the laminate is cured, you would have a honeycomb structure between the skins because the resin has filled in these channels. As you see here, the resin, if you have this reinforcement at the top and bottom and then Soric in the middle, the resin will flow longitudinally and then it can easily impregnate the reinforcements at the top and bottom because the distance here is much shorter. Here is a film showing the, let's say, resin flow in a laminate, in a vacuum infused laminate made by Soric. You can see the length of the laminate here. It's 90 centimeter. And here you can see the time of, let's say, infusion. So it will fill in the laminate within, I think, 11 minutes. Yes. Here I have. Here you can see different Soric grades and basically the flow speed. You can see in the XF, in the extra flow, you can see it's flowing much faster than the two others. And in the LRC, low resin consumption, it's the, let's say, slowest. Here I have a video for, let's say, using Soric in vacuum infusion.
Hello, my name is Wartstein from Lantor, and in this film we are going to make a simple infusion using Soric. Our goal is to produce a flat sandwich panel of 6 millimeters thickness, consisting of Soric XF4 and two 1 millimeter thick glass fiber reinforced skins. We will be using polyester infusion resin to create our panel. We start our layup with the placement of our materials on our mold, which is the polypropylene table surface. We build our sandwich with only glass fiber mats and our Soric. Next, we plan out our vacuum and resin infusion lines. The most robust thing to do would be to infuse along the shortest distance, which would be the width. On a large surface, the resin feed line can even be placed on top of the layup. However, in order to demonstrate the resin flow capabilities of Soric, we will be infusing along the length of the layup. Traditional vacuum infusion will require a flow mesh to facilitate penetration of the resin into the materials, and an equal length of peel ply to remove the flow mesh after the resin is cured. We will not be using these large pieces, which will become waste because it will be the soric that is going to facilitate the resin flow. And unlike the flow mesh, soric is part of the final product. That means that our resin feed line comes here. We stretch out the spiral hose so it stays open. And we position the spiral hose to make contact with the soric to assure an optimal resin flow, aided by a small piece of peel ply and flow mesh where necessary. Our vacuum line goes against the opposite end. You'll have noticed that our soric runs the entire length of the laminate. So placing the vacuum line directly against the laminate will be counterproductive. The resin can then flow freely into the vacuum system, which will be a waste. Therefore, we will be employing a resin block. There are several commercial resin blockers on the market, but we will simply be using Corvette XI to slow down the resin flow at the end of the infusion. A 6 centimeter strip of Corvette XI, 3 millimeter, will do nicely in most cases. In order to add the resin to the glass fiber and soric, we will be using a vacuum pump. And we will create a vacuum bag around the materials using this film and the sealant tape, which will create an airtight seal between the film and the table. When all our materials that go in the vacuum bag are in position, we can proceed with making the vacuum bag itself. We already placed an outline of sealant tape around the material, so now we also prepare where we want our hoses to enter and any other spaces where we want extra vacuum bagging material. The vacuum pump will be protected from resin flowing into it by a resin catch pot and a resin brake, which will slow down the flow before reaching the vacuum system. That covers our material choices and their placement. Let's get on with the infusion. Us on LinkedIn, Facebook, and Twitter for more updates from Lantor. And should you have any technical questions about our Lantor product, you can always contact us on lantor.com.
Okay, so as we saw, application of soric, we can use soric in vacuum infusion, and basically what soric does is that you can impregnate the laminate from inside. So basically the resin will flow through the soric and then go to the top and bottom layers, which are close to the soric. It can be combined with foam cores in one laminate. Also, you can use soric because of its flexibility and drapability. You can easily use it in complex shaped areas. And also it's possible to stack multiple layers of soric. As you can see here in this laminate, we have a layer of finish mat at the top. Then we have a glass layer, and then we have soric TF2, which also helps as a print blocker. And then you have still glass layers, and then you have the main core here, Soric XF4. And then you have your glass. Here we just wanted to demonstrate the effect of Soric TF on the print through. So this is a laminate made with our skin core. Here in this case, it's made without Soric TF. And from the reflection of the light, you can see that there is some glass fiber print through, and also there is some core print through. And in this case, when you use the same or make the same laminate with Soric TF, you get a smooth surface without print through. So that's the effect of Soric TF. Then going to the next product, finish mat. We have different surface veils which are used for different applications. We have the D77, which is used for closed mold processes like RTM. Basically, this absorbs a very thin layer of resin at the surface. Also, we have finish mat D88, and also we have finish mat 6691. So these two surface veils, they are suitable for filament winding and pultrusion. D88, it's a unique combination of having a relatively high tensile strength, but also having a permeable structure. So basically the tensile strength helps to easily use this veil in pultrusion and filament winding. And the open structure, it helps to absorb resin and enhance the quality, surface quality. So these are needle punched. This D88 is needle punched, and this 6691, this is a chemical bonded polyester veil. And also it helps to uptake resin, basically have a very thin resin-rich layer on the top of the laminate, which serves as surface finish, also as a chemical barrier to protect the laminate. Looking at finish mat, this is the structure of different, let's say, grades. This is the data sheet. You can see the thickness starting from 0.3 going up to 0.65. The roll length, the width, the resin uptake, the dry weight, it is from 20 GSM up to 80 GSM. We have the D77 and D88, this is needle punched, and we have the 6691 as the chemical bonded. Basically these two are the fiber type are PON, and the rest are polyester. So basically in terms of chemical resistance, the veils which are made of polyester fiber, they are slightly reinforcing. They help to resist against erosion, solvents, acids, also weather, harsh conditions, but they are opaque in resin. So basically, if this is for example, carbon visible laminate, we usually advise to use the PON-based or polyacrylic fiber-based veils, because that one becomes transparent in resin. And this is also, these pan-based fibers are also resistant to solvent, acids, bases, and weather. So as an example, for osmosis protection of the laminate using finish mat, we have made 3 laminates, 3 glass polyester-based polyester resin laminates. This one is without skin coat and without finish mat. This one is with skin coat but without finish mat, and this is with finish mat. And we have placed these laminates for 2 weeks in water tank at 60 degrees. And we have studied the osmosis effect. You see here a lot of blisters happening, here a little bit less. And when you are using the finish mat, you see this surface without blister. So the next product, it's a relatively new product called Techcore, which we are still developing new products within this brand. As mentioned, we are naming our products based on the process in which they are used. So Corvette for open mold and Soric for vacuum infusion. And we are developing this Techcore brand basically for higher pressure and higher temperature applications for processes like RTM, autoclave, thermopress, wet compression molding for this kind of processes. And as you can see from this chart, I have compared the pressure and temperature resistance of these cores during process. As you see, the lowest is Corvette, then you have Soric, and then you have the Techcore variants TG90 and TG120. And basically the most resistant core under temperature and pressure, it's the TG180 HP. And basically this resistance comes from the type of microspheres which are used in these products. So for example, for this TG180, the microspheres only become active when the temperature is reaching around 180 degrees, and they can be still effective up to 220 degrees. So this is the range where microspheres are still efficient. And for the other products, like for Soric, a range of temperature between 125 to 180, 185. That's the range of temperature where microspheres become active. Of course, it is a combination of pressure, temperature, and duration, which would basically be which would determine the resistance of the core. As you see here, when you apply pressure, you would lose some thickness of these cores. I will show you in the next slide. Basically, we have 3 commercial products in this brand. Of course, we are developing further. We have some R&D variants also. But what we have now is 3 cores, TG90, TG120, and TG180. So basically this is 90 GSM aerial weight, 120 GSM aerial weight, and this is 180. And the initial thickness is between 1.5 to 2 millimeter. This is the initial thickness because when you apply the autoclave pressure, for example, 6 bar, then you would lose some thickness. So you would go up to 0.2 for this one, 0.6 for this one. Of course, these numbers, they are, let's say, the end thickness or the residual thickness that is dependent on multiple factors. And these numbers are reported only for one case. So depending on the resin that you would have, depending on temperature the process is and in which order are these pressure and temperature applied, these are all things which determine the residual thickness of the core in autoclave or in thermopress or RTM also. Here, some laminates based on a woven prepreg and based on this thermopress cycle. So this cycle is 20 bar, 140 degrees and 5 minutes. And we had made two types of laminates. We had made monolithic laminate, and we have made also a laminate with adding one layer of Techcore TG180 in between the carbon layers, so in the middle. So here we have plotted the panel stiffness versus panel weight. The blue line shows you the monolithic laminate, and the red line shows you the micro sandwich, which is made by using the Techcore layer in between. So as you can see here, if we have two laminates which have the same weight, like 1500 GSM as the panel weight, you can see that for sandwich option, you have about 40% improvement in the bending stiffness. And on the other hand, if you have the same panel stiffness, you can see that for sandwich laminate, we have about 200 GSM lighter weight. So the same effect you should be able to see in the material cost and also the environmental impact of the laminate. So going from monolithic to a sandwich laminate, we save the cost. So basically we can either substitute a few layers of carbon by using the core instead of carbon layers. So that helps in saving the cost and also reducing the environmental footprint. So if you have, instead of like a few carbon layers in the middle of the laminate, which don't have that much effect on the bending stiffness, if you substitute it with a Techcore layer, which is made of recycled fibers, you are substituting carbon layers, which are very extensive in terms of, very energy extensive in terms of production with some, let's say, recycled material. And you are reducing the carbon footprint of the total laminate. So there is one subject about high volume production. So as you know, like processes like autoclave or hand layup or vacuum infusion, basically these are for low volume production. But when we are talking about transport segment, sometimes we are talking about really high volumes. And basically, so it means that we have to use production methods which have shorter cycles and basically suited for higher volumes or continuous production methods. And basically the good news is that Lantor materials, they are basically adaptable to most of these production methods, as I mentioned in the previous slides. For example, for RTM or for wet compression molding, where you have higher volumes, you can use our products. But also, if you look at a bus, for example, a bus structure, you can probably see a frame which is made of profiles and panels, so really large panels. And basically, both of these elements can be made with continuous production methods. So they can be produced by pultrusion, the profiles, and the panels, they can be produced by continuous lamination. So the good thing is that our products can be used in both. So our products are coming in the form of rolled goods. So basically, you can use the rolls in these continuous production methods. For example, here we have done a trial. So we have converted this full glass laminate or profile to a profile with having the core in between. The black one that you can see here is a Techcore, it's a TG90. And basically here we were able to easily reduce about 15% weight just by substituting some glass fiber by the core. And also continuous lamination where you have rolls of reinforcement material. Then you can have rolls of Lantor core and surface felts and resin all going into the machine, into the continuous lamination machine. And at the end, you would have panels which are continuously produced, and you can cut them to the desired lengths. So basically, the products are easily adaptable to high volume production. I have a few slides about material performance. Here we have put the Corvette laminates. Basically, it's a laminate made of 600 GSM biaxial glass as the top and bottom layers, and then a 3mm core in between. And then these are laminates which are made by hand layup for Corvette or by vacuum infusion for Soric. And we have compared them to a few, let's say, foams and also cork. This is the Arex C70.75, and this is the Gurit Corcel A500, and this is cork. And these laminates are made, let's say, the blue ones are made by hand layup, and the orange ones, they are made by vacuum infusion. As you can see, the weight comparison of the panels, you see foams are sometimes a little bit, let's say, lighter, or in the same weight range, I would say. But what I wanted to show you is that in the design, well, actually weight is important, but also the mechanical properties are important. So we have here compared the mechanical properties of these laminates in terms of flexural strength. You see here, Corvette and Soric are doing very good. In terms of tensile strength, so basically this is a flat-wise tensile strength test, which we are doing for our product type certificates. You can see, again, Soric and Corvette are doing very good compared to the foams. The shear strength, you see really higher values also for shear strength. And the compression strength also, you see really good values. So the reason behind it, that in terms of mechanical properties, our cores are behaving very good if you compare them to the foams, is that the core allows for the resin, the Lantor core allows for the resin to impregnate through it. And basically this resin is impregnating through the core and making bridges between top and bottom skins, which contributes to a lot of mechanical properties. There are some specific performance questions also, like for making structures. Can we screw into Lantor cores? Can we use screws? Will it absorb water? Does the core rot? Does it weaken at high temperatures? So the good question, the good answer is, let's say, yes, we can easily use screws to fasten these parts. Here I have a comparison of different materials in terms of screw holding capacity. So per millimeter depth of the screw, you need this force to get the screw out of the part. You can see for the CSM chopped strand mat glass, 20% glass. This value is the highest, it's 22 Newton per millimeter. Then you have the plywood, and then after that you have the core mat and Soric. And then balsa, PVC foam, and polyurethane foam, they are basically, they cannot have any screw retention. Will it absorb water? Basically, we do tests for our type approval, and we test our cores. Basically, we place the laminates which we make in the water bath for 28 hours, for 28 days, sorry, at 35 degrees, and we measure the mechanical properties afterwards, and this should not drop, and we see that it's not dropped. So does it weaken at high temperatures? Again, the question we can answer by the fact that most of the integrity of the laminate, when you are using our core, it comes from the resin, because the resin goes through the core, it impregnates the core, and it makes a structure there. So behavior at high temperatures, that dependent on the resin and not the core. I have some impact studies also we have done for two laminates, a full glass laminate here, and a sandwich laminate, a Soric laminate. Basically, these two laminates have the same bending stiffness. So this sandwich laminate is designed such that the bending stiffness is exactly the same as the full glass laminate. And you can see here the impact tests. Here, this is the top view, and this is the bottom view of the full glass laminate. Let me check if I can play it again. Yes, so this is the bottom view. And you can see this bottom glass layer is broken. And we have the Soric option also. And this is the bottom view. And you can see Soric is absorbing most of the impact. And the bottom glass fiber layer is intact. It's not broken. So yeah, this is basically, this says that the Soric absorbs all the energy. So basically this this is one of the, let's say, important properties of these sandwiches, where instead of a monolithic structure, you have a sandwich where you have two skins, and if under impact one of them is, let's say, damaged, the other one can still be intact and protect your part or your vehicle. Here I have some application examples for the transport segment. Here for the buses, this is a company in Czech Republic who is using our Corvette XE for bus panels to save weight, also to quickly build up the layers, because they are using hand layup. so they can quickly build up thickness and also use it for increasing the bending stiffness. Another case is in train interior panels, where here Corvette XE is used. Again, this is a hand layout process. It is used in combination with ATH filled polyester resin for fire retardant, let's say, properties. And it helps to save weight, quickly build up the layer, and increase the stiffness. Another case for caravans, Soric XF3 is used in vacuum infusion. Basically, it helps the resin transport because it has channels. It is used in combination with other cores, polyurethane core. There is no need for extra infusion media, or there is no need for grooving the core. It helps to increase the stiffness also. Here another application for airport crash tenders. Soric SF is used for the body panels, and basically the advantage is to improve the resin flow inside the laminate, and these panels are made by RTM Light. This is a company in Austria. Here another case of using Soric XF to create extra stiffness, also act as an impact barrier in these panels here for this truck in the transport segment. And this is also made by RTM Light. Another application, this one is for finish mat, D7760, for the top slippers here, for the surface appearance, for the surface quality. Finish mat is used in RTM Light. Again, another case of finish mat for this company in Belgium. Again, for top slippers, but also for spoilers and deflectors. For Class A surfaces, they use the D7760 in RTM. And finally, applications of Techcore for passenger cars or motorsport cars. Like we have a lot of applications with Audi, Porsche, Lamborghini, and others for exterior and interior panels. There is a possibility for using this material also for battery enclosures, because this is a really thin laminate. We call it micro sandwich. And for battery enclosures, some of the OEMs are looking for sandwich structures because the sandwich, if there's an impact at one side, the other side can still be intact. And also these are micro sandwiches, so they are really thin. And being a thin laminate, it means that you have more space inside the battery enclosure for your battery. So you can use the space for battery and having a longer range. Yeah, for these applications, Techcore has been used, especially for exterior panels, for body panels. It has been used as a core, it has been used as a print blocker, also as a mold filler when you have an RTM part, for example. So in different processes from RTM to prepreg, autoclave, and compression molding, this has been used. So thank you for your attention. I think we can go to questions. If you have questions, you can also ask us later via this email address.
Thank you, Mr. Ali Khan. It was really wonderful knowing all the solutions that Lantor provides. So thank you so much. There was a great knowledge shared about Lantor. I think many of us got to know like great products that Lantor produces. So the session is now open for Q&A. So I'll request everybody, you can now unmute yourself and you can ask the questions. There are a couple of questions already in the chat, so I'll request them to just unmute yourself and ask the questions. Yeah. So I request Dishant, you had a question. Then Nico, you had a question. So I request you to unmute yourself and just ask the questions. Could you please?
Hello, sir. Hello. I would like to know that is it possible to use Lantor Soric in autoclave process?
Yes, yeah, for autoclave, yes. So basically, you can use it, as I mentioned, you can use it in autoclave, but the end thickness of the core, that would depend on a few different factors. You can use the core dry, or you can pre-impregnate the core. So there are some manufacturers, some pre-preg manufacturers who already make a pre-preg out of the core. And that can have an effect on the end thickness of the core. Also, depending on your pressure, temperature, and the way you apply it, like the order of applying the pressure, that can have an effect on the residual thickness of the core.
Okay, thank you, sir.
So this is Techcore, which is basically Techcore or Soric. These are suited for autoclave also.
Thank you, sir.
Yeah, no problem.
Hello.
Hi.
Can you hear me?
Yes.
I make surfboards, and so I'm wondering which mat I could be using. I do hand layups, but I was basically wondering if through a hand layup I would get a really stiff part, because in a surfboard I do want the part to flex actually a certain degree. So if I get a really stiff part, the performance of the surfboard is not anymore the way I want it to be. So I'm kind of wondering if I should be using the first one which you were talking about for the hand layup, or if I should be using rather a Soric and put it in a vacuum bag. I'm not doing infusion as such, but if I would be putting it into a vacuum bag, if I would get still a rather flexible part. Basically, I'm looking for a part that can still flex to a certain degree, but has a good amount of impact strength.
Yeah, I think that depends on the end thickness. Of course, I cannot answer you now like what thickness, because that depends on the laminate that you have. But basically, you know, like if you increase the thickness 2 times, it means that you're increasing the bending stiffness 8 times.
Yeah.
So yeah, so if you look at our brochure, you can find out, for example, for Soric products, you can find out how much thickness loss you would have after vacuum, and then you can input it in your calculations to find out the, let's say, end thickness of the surfboard which you need.
Yeah.
And yeah.
And so the Soric fiber could be used as a basically doing a hand layup first, and then putting the entire part into a vacuum bag. That would also work, or is it really meant just for an infusion process?
No, it's not. So it can still work with let's say hand layup, but yeah, it's So I would say both infusion and hand layup, but the core mat one, if you want to use in infusion, basically it would be pressed, and you would not have any resin flow anymore, because it's like the permeability is closed.
Right.
It's not pressure resistant, the core mat one, but the
Okay.
solid one is more pressure resistant.
So if I would put it into a vacuum bag, even just for pressing it onto the foam core, then it would be better to use a Soric and not the core mat.
Yeah, sure. If you are vacuum bagging, then Soric, yeah.
Okay. And for the core mat, to do a hand layup, the final fiberglass which I will be putting over the core mat, then is it easy to apply by hand over it, to not get bubbles and things like that?
No, I think I showed you the video.
Yeah.
There are also more videos on our YouTube channel and also on our LinkedIn. So
Yeah.
you can, if you follow the steps, basically it shows you how to do it in the perfect way.
Okay. And just one last question about the drapability. In the video that you were showing, it was applied into a mold, right?
Right.
So if I would be applying it on a surfboard, I have to apply it over the rails, which can be a very tight curve also. So, and even sometimes just a fiberglass layer has to be applied very gently, and to pull the glass fiber really over the rails. It's easy to get bubbles along the rails in certain areas. So would the core mat allow these contours, or would it be better to tape it down or something like that?
Yeah, I think depends on the, like, how sharp is your contour, but I think, yeah, it's, if you can, yeah, it can easily drape to any kind of 3D shape. Probably you need to cut somewhere or something like that. I don't know the shape exactly, but yeah, that's one of the advantages of this course. You can easily drape it to any 3D shape, sharp corners. So those are one of the most, let's say, used applications, those sharp corners.
Is it slightly stretchable?
Yes, yeah, yeah.
Okay, okay.
Yeah.
Thank you very much.
No problem.
Very nice presentation. Thank you.
Thank you, Nico, for your kind words. So, do you have any further questions coming in? You can just unmute yourself and ask, or you can put it in the chat. So, we have a question in the chat by Mr. Ravi. So, Ali is asking, we have started exploring core mats for our new product. Can we get few samples?
Yeah, sure. I think it's the best to get in contact with Link Composites. They are our, let's say, official distributor in India. So I think you can get it through them.
Thank you, Ali. So, Ravi, I'll just drop the connect of Mr. Sandeep Kalyan Sethi, who is there in the session as well. So, he is from Link Composites, and you can surely connect with them for the samples. Any further questions?
I have one more question, sorry.
Yeah, please, Nico, go ahead.
About the finish mat. So for my product, for surfboards, would it be advisable to use a finish mat over a core mat?
Yeah, I think depends on. Well, actually, for hand layup, I think it's better to how do you make your laminate? Actually, can I ask like what layers you put there?
So basically, I start with an EPS foam core, which I hand shape, and then I apply fiberglass. So I have two different weights, 4 ounce and 6 ounce, which I think translates to about 140 GSM and 220 GSM approximately. So right now I'm using just those weights of just fiberglass. So I do a hand layup Then once the layers get tacky, I put a filler coat, which I then sand, and then a finish coat, which I again sand to get a nice and smooth finish. So I've been struggling actually to get a really nice finish. I quite often have issues with little bubbles that burst. I use a heat gun to get rid of most of the bubbles in the finish coats, but there is always some small issues which happen. And the images that I've seen now in your presentation with the finish with the surface mats, they look really nice. And so I'm just wondering, like, would it help in getting a nice finish like this, or is this really just in a molding process that you would get this kind of finish?
Yeah, I think it helps you to have a very thin layer of let's say resin on the top. But I think this specific question, it's good to if I get you in contact with one of my colleagues, which is more expert in this area. So I think he can help you. If you can send us an email to the email that I showed you, composites@lantor.nl, I think my colleague can reply to that with specific instructions.
Yeah, let me just write that down. Composites.
Get inquiry from Mr. Nico. Yeah, Sandeep here. You just send us the inquiry so that I can forward to that.
Okay. That's composites@lantor.nl. Yes?
.com.
.com.
Yeah.
Composites.
Let me
Okay, Nico, you can find this email ID on the chat. It's of Link Composites of Mrs. Sandeep Kalyan. You can just email the inquiry to him as well, so we can take this further.
Composites@lantor.com. Right. Great, thank you.
Thank you so much, Nico, again. So, do we have any further questions? Thank you, Quality Shutters. They have written that we are using Lantor SF for panels. It's a useful product. Thank you so much. Could you share product catalog if possible? You can find the catalog, I think, on lantorcomposites.com. You will find all their products being very much listed with all great descriptions of the product. Okay, Jishant has this question. Has it been answered? Like, is it possible to use the Soric core in autoclave?
Yeah. So basically, many of our clients are using Soric TF or Techcore in autoclave, and I think also the previous question was about this one. So yeah, they use it either dry or pre-preg in autoclave.
There was another question. Can you elaborate when to use format XI versus XM?
Yeah, I think this question you have to ask via email to my colleague. I think he can answer you better than me.
Good. Sure. So for that, we are actually supposed to have two speakers today. With Mr. Ali, we were going to have another speaker, but unfortunately he got COVID. So let's hope he gets well soon. So do you have any further questions? Okay, Mr. Abhijit Patki has a question. For the Lantor format to use in 3D shapes, do we need to wet it before we apply it to the mold?
Sorry, I didn't hear the question. Can you repeat?
Yeah, it's in the chat if you can read. For the Lantor core mat to use in 3D shapes, do we need to wet it before we apply it to the mold?
Yeah, if it is a 3D mold, yeah, it's better to wet it outside and then apply it to the mold.
So thanks. Do we have any questions? We're done for today. Okay. Otherwise, like if anyone is typing, let's wait. So to know more about Lantor Composites and Link Composites, you can visit their websites, elink.co.in, if you want to know more about Link Composites, and if you want to know more about the solutions that are being displayed today in the symposium, you can visit lentorcomposites.com. So for any inquiry if you have to Lantor, you need to go, like, inquire it via Link Composites because they are their channel partners in India for distribution of Lantor solutions. So I think there are no further questions. Do we have any? Okay. So everybody is appreciating the session. So thank you so much, Ali. It was really wonderful to have you. It was really it's, on the personal basis, if I say it's one of the best, symposiums I've ever hosted. Thank you so much, Mr. Ali, for just you were really fantabulous while explaining yourself, the solutions, the Lantor products, and everything. So I think it was a really great session. If there is something you want to say to the participants, like just to end the session, any kind words.
Well, thank you for your time. Thank you for your attendance. I think if you need samples from us, products from us, please contact Link Composites. Yes. And in terms of technical questions, you can always reach us at composites@lantor.com.
Thank you so much, Ali. Thank you. Thank you so much, Ali. He was from Lantor Composites. I request Mr. Sandeep Kalyan Shetty, who was the face of Link Composites today, to just say a few words.
On behalf of Link Composites, I would like to thank you, Mr. Ali. We came to know that Word is not feeling well, so it's okay, but you have handled it. So thank you so much for your time. Okay, and if you have got any inquiries, please send us the inquiry.
Thank you so much, Mr. Sandeep. Thank you to Link Composites and Lantor Composites. So we love to host such amazing sessions on composites. That is what CECAASIA has been doing from long, and we promise to do it then and now always. So thank you once again, both of you, for being here. And to all the participants, the whole session will be uploaded on YouTube. So to revisit, if you missed something, you can revisit. We'll be sharing you the link. The link to the video will be mailed to you. So thank you so much. Will there be other sessions such as this? Absolutely, Nico. The CECAASIA keeps on doing such sessions, and you can always visit CECAASIA.com to find such symposiums and events and training sessions. So thank you once again, Mr. Ali and Mr. Sandeep. So before we leave, I'll quickly share. Yeah, so I'll quickly like to share about CAMX, which is going to happen in October from 17th to 20th in USA. It's one of the major events in composite industries, and we are very proud enough to share that we are the partners for CAMX, and it's a proud moment for us to share that CECAASIA will be will be hosting a Indian pavilion in CAMX, and we promise to get you assured support in all respects. Even if you're looking for MSME International Cooperation Scheme, there are many benefits that you can use when you're going out for the exhibition. So if you're eligible for the same, you'll surely get the MSME IC scheme. And apart from that, the big question is why to exhibit at CAMX 2022. So CAMX is like the Composite and Advanced Material Expo. It is the largest, most comprehensive composites and advanced materials event in North America. So you have the opportunity to showcase your product and services to the international market. So by here, I request Link Composites and Lantor as well. So you can be part of Indian Pavilion, like the SICA Pavilion at CAMX. You can exhibit the Lantor solutions and all the other solutions that are being provided by Link via other companies. So CAMX is the best source for new solutions, technologies, and ideas. You need your current and for your current and your future products. So CAMX will make it easy for you to watch the processes, the demos, the materials, and everything with the interactive displays and everything. So at one place you can generate more leads for yourself. And of course, if you are a local manufacturer just selling your raw materials or products locally in India or otherwise, you can actually see yourself exporting your products or your raw materials or your solutions to the global companies, the global composite fraternity. So please do please do let us know if any one of us is being interested in exhibiting at CAMX 2022. We'll surely help you with all the documentation and everything. Even if it's for applying visas and getting the like getting IC scheme from the MSME industry, so we can do all that for you. So with that, thank you so much once again for being here. I'm so happy again that we were able to do this. So soon we'll be seeing you with another symposium. I'll share there's one symposium going to happen on 25th. So I'll push all the details to all of you to your email ID. Thank you once again for joining us today. Thank you so much, everyone. Thank you once again, Link Composites and Lantor Composites for.
Prashant, thank you so much for your technical support.
Yeah, thank you so much. Thank you. Thank you, Ali.